Good day again, class. I'm again James Cedric Mojica, and your professor for today for our topic, which is infrared and Raman spectrometry, principles and instrumentation. Before we start our lesson, I have here proposed jumbled letters, and you will answer them and provide your insights or understanding about these terms. Number one is for number two, we have yes, scattering. So can someone please provide their um, understanding about the term scattering? Yes, thank you, thank you. Another one, yes, it is absorbance. So can someone please provide their insights or understanding about absorbance? Okay, thank you. You are correct. And for the last term, yes, we have vibration. So in spectrometry, what do you understand about vibration? What are your insight about the term vibration? Yes, thank you, thank you. So, for our learning objectives, at the end of the lesson, you will be able to explain the basic principles of infrared and Raman spectrometry and how they differ from each other. Then, identify and describe the concepts and techniques of instrumentations present in infrared and Raman spectrometry. Lastly, value the significance of infrared and Raman spectrometry in various real-world applications and how it enhances the accuracy and reliability of scientific analysis. So first, let's have a review. So can someone please provide their understanding, or it's a review for the basic concept of a spectrometry. Spectrometry is a method used to measure the intensity of light at different wavelengths as it interacts with a sample. The technique helps identify and quantify the chemical composition of a substance by analyzing the spectrum of light it absorbs, emits, or scatters. So now, we will compare absorption or and scattering. And someone please provide their understanding of how it differs in what we observe in our surrounding. In absorption, the color observed in a substance often results from the absorption of specific wavelengths of light. When a substance absorbs certain wavelengths, the remaining light is what we perceive as color. For example, a red apple appears red because it absorbs most wavelengths of light except those in the red region of the spectrum, which are reflected to our eyes. And in scattering, compared to the scattering, uh, mm, katulad ng absorption, scattering can also influence the color of a substance, particularly when it involves particles or molecules that are larger than the wavelength of visible light. For example, the sky appears blue due to Rayleigh scattering, where shorter wavelengths of sunlight are scattered more effectively by molecules in the atmosphere compared to the longer wavelengths. These scattered blue lights reaches our eyes from all directions, making the sky appear blue. So now we will proceed to our lesson proper, and we will discuss infrared and Raman spectrometry. So, infrared and Raman spectrometry are two powerful techniques used to study the vibrational properties of molecules. While they share similarities, they have distinct principles and applications. The infrared spectrometry measures the absorption of a infrared radiation by molecules. When a molecule vibrates, it absorbs specific frequencies of infrared radiation corresponding to its vibrational modes. The absorption of infrared radiation is governed by selection rules, which dictate which vibrational modes are active. A mode is infrared active if it causes a change in the molecule's dipole moment. Infrared spectrometry is widely used to identify functional groups, determine molecular structure, and analyze mixtures. It is particularly useful for studying organic compounds and inorganic materials. On the other hand, Raman spectrometry measures the scattering of light by molecules. When a mole is irradiated with monochromatic light, it can scatter the light inelastically, resulting in a shift in frequency known as Raman shift. The intensity of Raman scattering is determined by the change in molecular polarizability during vibration. A mode is Raman active if it causes a change in the molecule's polarizability. The Raman spectrometry is complementary to infrared spectrometry and is often used to study molecules with low infrared activity, such as symmetric vibrations. It is also useful for analyzing samples in aqueous solutions or opaque materials. So, these are the key comparison of the infrared and Raman spectrometry. In their principle, infrared spectrometry's principle is absorption of infrared radiation, while Raman spectrometry is the scattering of light. In their selection rules, the infrared focus on the change in dipole moment, while Raman is the change in polarizability. And in their applications, functional group identification, molecular structure determination, and analysis of mixture for the infrared, while the analysis of molecules with low infrared activity, aqueous solutions, and opaque materials for Raman. And they have same sample preparation, which is solid, liquid, and gas. And both infrared and Raman spectrometry are valuable tools for studying the vibrational properties of molecules. The choice of technique depends on the specific application and the nature of the sample. By understanding the principles and limitation of each technique, researchers can effectively utilize them to gain insights into molecular structures and properties. So, for the class questions, please raise your hand if you want to answer. Number one, what are the main differences between infrared and Raman spectrometry? That's right. Number two, how can infrared and Raman spectrometry be used to complement each other? So, can please someone answer? That is right. Next, what are the advantages and disadvantages of each technique? Yes. And lastly, in what situation would you choose infrared spectrometry over the Raman spectrometry, vice versa? That's right, you had a good point. Now, let us proceed for our class activity and please answer it orally since we are in a online modality. So, I will provide clues and you will answer. The first to raise their hand is the one who will have a chance to answer. Number one, I am used to identify functional groups and analyze mixtures. Yes, the answer is infrared spectrometry. I am often used to study molecules with low infrared activity. Very easy to answer. Yes, it is the Raman spectrometry. I am a technique that measures the scattering of light. Scattering of light. Yes, and very easy to answer infrared spectrometry. Lastly, I am a technique that measures the absorption of infrared radiation. Very easy to answer it. Is the clue in the sentence. Yes, the answer is infrared spectrometry. Now we're going to delve into the instrumentation used in infrared and Raman spectrometry. Understanding the components and principle of this instrument is crucial for effectively utilizing these techniques. So in this illustration, it is the infrared spectrometer. So in an infrared spectrometer, we have several parts. First is the source. It is a common, uh, um, the common source of for infrared spectrometry is a global, a heated ceramic rod that emits infrared radiation. And other sources may include nurse blower and a Michelson interferometer. Next is the monochromator. The monochromator isolates specific wavelengths of infrared radiation. Grating monochromators are commonly used, but Fourier transform infrared spectrometers employ interferometers to achieve higher resolution. Then, yung mawawala is the sample cell. The sample is placed in a cell that is transparent to infrared radiation. Gas cells, liquid cells, and solid sampling accessories are available. And the detector. Detector measures the intensity of the transmitted or scattered infrared radiation. Common detectors include thermocouples, bolometers, and photoconductive detectors. Now, let's dig deeper naman to the other spectrometry, which is the Raman spectrometry. So, in a Raman spectrometry, there is a Raman spectrometer. So, this is the illustration diagram of a Raman spectrometer. So, we have here the laser source. It is a high intensity laser that is used to excite the sample. Common laser sources include argon ion lasers. Then, similar to the infrared spectrometer, we also have the sample cell, hindi mawala. The sample is placed in a cuvette or capillary tube. Then we should have the scattered light. The scattered light is collected and analyzed. A filter is used to remove the realized scattered light, which is of the same wavelength as the excite, excitation laser. And similar to the infrared again, we have the detector. The scattered light is detected using charge coupled device or photo multiplier tube. So questions. Explain the key difference of infrared and Raman spectrometry. Yes, so very simple. The key difference we need to remember that is that infrared spectrometry absorbs light while Raman reflects light. So, can you please describe a real-life application of infrared or Raman spectrometry and explain how principles are important in the given application? Okay, thank you. So, I will discuss to you the real-life applications of both infrared and Raman spectrometry. So we can apply them in drug analysis and quality control. In the production of aspirin, infrared spectrometry can confirm the presence of aspirin by matching its characteristic absorption peaks, while Raman spectrometry can differentiate between different crystalline forms of the drug to ensure consistent quality. Another application is for pollutant detection and analysis. Infrared spectrometry is employed in monitoring air quality by detecting carbon dioxide levels in the atmosphere, while Raman spectrometry can be used to identify and quantify particulate matter in urban air samples. Another application is the characterization of materials and nanomaterials. In the development of new materials like carbon nanotubes, Raman spectrometry provides detailed information about the material's structure and quality by analyzing the characteristic peaks related to its vibrational modes. Infrared spectrometry might be used to analyze the chemical composition of polymer-based composites used in aerospace application. So, for quiz time, your favorite part of the lesson. 1. What is the main difference between infrared and Raman spectrometry? It is stated again and again in the discussion. You can answer it very easily. A. A type of radiation used. Letter B. Selection rules for active vibration. Letter C. The method of measuring the interaction with molecules. So comprehend clearly, comprehend effectively, and critically comprehend with the question. Number 2. Which technique is more suitable for studying molecules with low infrared activity? You can easily answer that question. Number 3. What do you mean by Raman shift? A. The change in wavelength of scattered light. B. The frequency of incident light. Letter C. The difference between the incident and scattered light frequencies. Number 4. What is the primary source of radiation in an infrared spectrometer? A. Laser. B. Globar. C. X-ray tube. For the last number, which component of a Raman spectrometer collects the scattered light? Letter A. Monochromator. Letter B. Detector. Letter C. Filter. So, for our assignment, for your additional activity that you will answer at your home to widen your knowledge and apply the concepts that you have learned for today, you will write a short paragraph, 4 to 5 sentences, about your understanding about the infrared and gamma spectrometry and how will it help you in your future career as a pre-service teacher in science. I will give one clue. It's for research, and you as a teacher you will participate in many research activities. So you will just explain 4 to 5 sentences about the application and the perks of understanding these concepts in your future career as pre-service teacher in science. So that's all for today. Goodbye, class, and good luck for your college journey.